Hi, my name is Effa MARLIANA binti MUSTAFFA from Bachelor of Science in Project Facility Management with Honours, BPFM. So today I will present to you about air conditioning and mechanical ventilation ACMV system. Introduction. For a tropical climate like Malaysia, air conditioning and mechanical ventilation ACMV system is required to operate throughout the year to maintain thermal comfort inside the buildings. ACMV system consumes about 60% of total energy consumption of a typical commercial building. Energy efficient design and optimization of ACMV system contribute significantly in reducing energy consumption and achieving cost savings. So ACMV systems are very beneficial to improve the quality of indoor air, but only if they function properly. ACMV systems include HVAC, which is heating, ventilation, and air conditioning systems too. So for case study, the building is Curve and X. Curve and X is located at Damansara, Mutiara Damansara. It is connected to the Curve shopping mall, which is located opposite across the road. So Curve and X consists of 10 floors, including 2 basement floors and 1 rooftop. This building is designed in a way that it maximizes the usage of spaces, especially by the implementation of the ramp car parks that did not have to compromise the public spaces on every floor. Mechanical ventilation system in Curve and X. So the first part is exhaust fan. Exhaust fans are used to eliminate stale, humid, contaminated air within an occupied space, since it supplies the energy necessary to cause air movement. Exhaust fans are usually just installed in a wall or a ceiling without ductwork. The exhaust fans in Curve and X are mainly installed in a wall, thus propeller-type axial flow fans are used due to the nature of airflow, where it is parallel to the axis of fan rotation. This means the air doesn't have to change direction in passing through the fan. Propeller-type axial fans are designed to move large volumes of air against low resistance using propellers or blades to provide airflow parallel to the shaft. So this is the example of exhaust fan in low voltage switch room at Curve and X, and the second picture is the exhaust fan in lift motor room at Curve and X. So this picture shows the exhaust fans at car park basement, Curve and X. So genset room ventilation silencer. Noisy genset motors and radiators require airflow for cooling. To enclose the generator for noise control and still provide sufficient airflow for cooling the genet and reduce noise concurrently, the application of acoustical silencers and louvers offers superior noise reduction while accommodating the specified CFM for motor and radiator cooling of the generator. By housing generators in an enclosed space, this poses a challenge from ensuring the engines are well ventilated for them to run efficiently. The ventilation silencers serve the purpose of ensuring the correct level of ventilation is achieved, whilst minimizing the effect of noise in areas adjacent to the plant room. Moreover, it is also able to provide a suitable level of filtration, ensuring the air entering the combustion chamber is as pure as possible. This is pictures of ventilation silencer. Second picture is filter in the ventilation, and the third picture is ventilation silencer in genset room and X curve. So about pressurized fan duct. So what is the purpose of pressurized fan duct? The purpose of pressurized fan duct is to introduce fresh air into the specified area required. The run and standby fans and control equipment should be housed in a separate plant room or outdoors, and the inlet should be protected from smoke. The system consists of installation of fan with an electric motor mounted in an insulated compartment. The outside air is captured through a shutter that has a particle filter. The insufflating of air to the escape stair occurs through the air release pipe generated by the fan, the ductwork, and outlet grills to provide distribution of air exactly where it is needed. Air is automatically released to prevent unwanted pressure built up in the adjacent spaces. So this may be automatic vents, natural shaft, or mechanical extract systems. So the pictures shown here is shutters which control the flow of outside air into the distribution duct are operated by the exhaust fan thermostat. So you can see that thermostatically controlled shutters, fresh air inlet, recirculated air, pressure fan, then air distribution duct in the attic area. So the second picture shows the pressurized fan duct in basement car park, curve and X. For escape stairs pressurization system, the escape stair pressurization system is a form of mechanical ventilation system where it maintains positive pressure in critical state area to prevent smoke from entering the stair. A pressurization system has three main components. The first one is supply air, second is pressure relief, and the third one is air release. So for supply air, air is injected into the area that is protected. So pressure relief to prevent overpressure when doors are closed. And the third one, air release, is for smoke to be released from adjoining fire area. Normally in commercial buildings, pressurization is normally carried through up to the final door to the accommodation, with air release provided from the accommodation. Stairs and lobbies are usually pressurized with air release from the corridor. The system is expected to run in the event of fire outbreak, and so it must be triggered on by the same system that starts the automated fire alarm system and firefighting system. It must also be powered by a dedicated power source that operates the firefighting system as general power system shuts down in the event of fire. So the first picture is pressurization system. And the second picture is fire escape route. Damper. Move on to damper. What is exactly a damper? A damper is a device used to control the flow of air in a ventilation system. The control of airflow is accomplished by varying the resistance to flow created by the damper, much as a valve does in a water system. So pressure relief dampers are used to release internal excess air pressure in the closed door condition from the stairs area. They usually have adjustable open pressure, which can maintain a relatively constant pressure at various airflows, and closes upon a decrease of referential pressure. So it is quite interchangeable. So this should be ducted to discharge directly to the atmosphere independent of the wind direction. So this ducted discharge directly and it follow the wind direction. And damper are set to a start opening of a 50 Pascal pressure differential. So this is the pictures of damper at level 7 emergency exit door at curve and X. And the second one is damper at the staircase area at curve and X as well. So we move on to jet fan. In an enclosed car park basement or the level above normally require ventilation system to help the firefighting operations. This system also helps to prevent carbon monoxide build up during emergency like fire outrage, where the jet fans propels the smoke out of the car park area. So the jet fan ventilation system is also known as the impulsive ventilation system. It is based on several small, strategically located high-velocity jet fans mounted directly beneath the ceiling. So the pictures of jet fan at car park curve and X. and Kruger jet fan at car park, curve and X. So this picture shows jet fan system in a car park. You can see that the underground level 1, jet fan, ground level, underground level 2, discharge to atmosphere through the jet fan system in car park. Air conditioning system in curve and X. So we will discover about air conditioning system in the building of curve and X. Curve and X utilize mainly a centralized control system for its air conditioning system. So basically a centralized air conditioning system is controlled in one control room where everything will be routed back to a single device. Curve and X does not have its own cooling tower. They buy chill water from district cooling plant situated at the curve, just next to it. Chill water is supplied to the heat exchanger through a link bridge, pumping chilled water to air handling unit, AHU room or fan coil unit FCU, and then to the equipment that supplies cool and refreshing air and extract of contaminated air from spaces. So the system goes vice versa, such that it has a constant supply of fresh air and extract of contaminated air from spaces. So AHU, which is bigger and more complex than FCU, it is used to ventilate the entire building, whereas the latter will only be used in smaller and local spaces only. Neither AHU or FCU is located at the car park, as these areas do not require chilled air supply. So this is the picture, a diagram about centralized air conditioning system cycle at curve and X. So the curve, the link bridge, and the inlet is 6 degrees Celsius, and then it goes back to 12 degrees Celsius primary to the curve, and heat exchange here HEX. We have HEX room 14 degrees Celsius, then it goes up 7 degrees Celsius to HU room 10 degrees Celsius, and then 18 degrees Celsius and to the heat exchange room. So the green arrow shows the chill water return, CHWR, and chilled water supply. So it will supply and it will supply, then it will return back to the system. It is like a closed loop system. Okay, so for district cooling plant, district cooling system comprise of collective equipment to produce and distribute chilled water. Chilled water is produced by production plants and distributed by water pipes to buildings equipped with energy transfer stations. So the chill water then supplies some of its cooling properties to the building's installations. It is located at the curve, which is situated opposite of the curve and X. Each building has specially designed units to use this water to lower the temperature passing through the building's air conditioning system. So the output of the district cooling plant is sufficient to meet the cooling energy demand of dozens of buildings. This can replace any type of air conditioning system, but primarily serving large buildings which consume large amount of electricity like curve and X. District cooling can be run on electricity or natural gas and can use either regular water or seawater. Along with electricity and water, district cooling constitutes a new form of energy service. Instead of using a chiller, district cooling plant is used to conserve and minimize electricity usage. So this is the diagram of district cooling plant from the curve. You can see over there the district cooling plant. So this is the top view of the curve area. So we can see that the first red square shows the district cooling plant, and then the link bridge, the second red square showing the link bridge, and the third red square show the curve and X, which is opposite the curve area. This is the top view for the curve area. So move on to the next slide, which is link bridge. Curve and X is a supplementary building of the curve. So therefore, it is possible for KFNX to buy chilled water from the district cooling plant due to its substantial amount of chilled water supply. The district cooling system therefore involves three key components: the production plants, the distribution network, and the energy transfer stations. So the chilled water is delivered via a link bridge through insulated pipelines to cool the indoor air of the building within a district. The cooling system operates in closed circuit and includes at least two water pipes, one of which carries the chilled water to the end user, and the other which carries it back towards the production plant. So the chilled water is pumped from the district cooling plant through the link bridge and into the heat exchanger room located at level 2 of KFNX. So the picture shows link bridge connecting the KFNX. And this picture shows chilled water supply and return pump in heat exchanger room KFNX. So heat exchanger, HEX. Heat exchanger is used to convert water temperature from approximately 2 degrees Celsius to 7 degrees Celsius. Then it will transfer the chilled water from high pressure pipeline, which is from district cooling plant, to the lower pressure internal system towards the AHU or FCU, the room. After its usage in the AHU or FCU, the warmer water returns, which is around 12 degrees Celsius to 18 degrees Celsius, to the heat exchanger for cooling again, like a cycle. So this forms like a cycle. It will return back and then it will give back, like that. So the type of heat exchanger used in annex is the plate heat exchanger. The plate type heat exchanger is the most efficient type of HEX with its low cost, flexibility, easy maintenance, and high thermal transfer. The HEX is composed of multiple thin, slightly separated plates that have very huge surface areas and small fluid flow passages for heat transfer. So this type plate arrangement normally has lower volume and cost than the shell and tube heat exchanger. The plate type heat exchanger has now been increasingly practical due to the advance in gasket and brazing technology have made. So in HVAC applications, large heat exchangers of this type are called plate and frame. These heat exchangers are normally of the gasket type to allow periodic disassembly, cleaning, and inspection when used in open loops. So there are many types of permanently bonded plate heat exchangers, such as deep braze, vacuum braze, and welded plate varieties, and they are often specified for closed loop applications such as refrigeration. So the plate heat exchangers also differ in the type of plates that are used and in the configuration of those plates. The first picture shows that CHWS and CHWR piping in hex room, KFNX, from left. So the middle picture shows that heat exchange pump in hex room, KFNX. So the third picture, the most right picture, is heat exchanger in hex room, KFNX. So this is the heat exchange room located, the hex room located at level 2 of KFNX. And the location of hex room in KFNX for second floor plan. So move on to air handling unit, AHU. So air handling units, AHU, sometimes referred to as air handlers, form part of the heating, ventilating, and air conditioning system (HVAC) that are usually to supply and circulate air around a building or to extract steel. So fundamentally, an AHU system can supply in a range of sizes and with a variety of capabilities, but typically they comprise of a large insulated box that houses a fan, heating and or cooling elements, filter racks or chambers, sound attenuators and dampers. In most situations, the AHU is connected to an air distribution ductwork. Alternatively, the AHU can be open to the space it occupies. Supplied air passing through the AHU is filtered and is either heated or cooled depending on specified duty and the ambient weather conditions. So basically, air handling units will be connected to the ductwork with building that supplies air to and extracts air from the interior, but they can be used to supply and extract air direct to a space, or they may be located on a rooftop units or RTU. Rooftop units, RTU. For heating or cooling, AHU may be connected to central plant, such as boilers or chillers receiving hot or chill water for heat exchange with the incoming air. Alternatively, heating or cooling may be provided by electric heating elements or direct expansion refrigeration units built into the air handler. So, air handling units can be used to recirculate a certain amount of stale air within a building, mixing this with fresh air to reduce the amount of air conditioning that is required. They can also include heat recovery, recovering heat from return air and using it to warm the supply air. So, pictures shown here, the first picture is supply duct in AHU room. The second picture shows the air handling unit, AHU, and the third picture shows the return duct in AHU room. So the air handling unit diagram, it shows that the return air, fresh air, insert the mixing section and mixing filter to the process of cooling coil section, and then to access section, heating coil section. Then it will humidify section, is humidifying section, fan section, attenuator section, and then it will go through mixing filter. Then it will go to discharging air section, and then the outlet is supplied air. So this show that AHU room located on top of the roof of curve and X. This show the location of AHU room in curve and X. This is from the roof plan. So chill water cassette fan coil unit, FCU, fan coil unit. Curve and X utilize a commercial-based chill water cassette fan coil unit, FCU. There is a total of 172 FCU in the building, and which uses chilled water as a cooling medium. FCU consists of only a fan and a heating or cooling element, which is located within the space they are serving, and generally not connected to ductwork. They may either just recirculate internal air, in which case a separate ventilation system is required, or may introduce a proportion of fresh air that is mixed with the recirculated air. So the principal advantage of installing a fan coil unit system that solely employs water as the cooling medium is that there is no need for the specific checking and maintenance demanded by the F-gas regulations pertaining to those installations that necessitate the presence of refrigerant within the building envelope. So fan coil units are more economical to install than ducted air handling units due to their simplicity. So basically the FCU is more simple. However, they might have bad acoustic qualities and can create vibrations because the fan is in the occupied space. Fan coil units are supplied with chilled water and hot water from central boilers and chillers. They are generally referred to as two-pipe, either heating or cooling, or four-pipe, both heating and cooling units. So each chill water cassette fan coil unit temperature can be adjusted to user requirements, and adjustable louvers allow efficient distribution throughout the entire building itself. So this picture show chill water cassette fan coil unit in curve and X. The FCU located at the ground floor reception. and the total area covered using chill water cassette fan coil unit section BB. Split unit system. Several areas of Curve and X have split unit air conditioning because these areas may still have occupants during off hours. It is actually mandatory to have full ventilation in the occupied space. Split units are placed in the office and the security, where the occupied space appear to be smaller than the commercial open spaces. Air conditioning ledges were also designed to place the compressors for the split units. In split air conditioning unit, the amount of cold air entering the room is controlled by thermostat or a remote control. This is to elongate lifetime of mechanical device such as transformer or the genset and to maintain optimum thermal comfort. Split unit system has the advantage of being more compact in comparison to a centralized air conditioning system. So this is the diagram showing split unit air conditioning system. The number one shows compressor, condenser, metering device and evaporator. Then it go to compressor. The evaporator will supply air out to the air conditioning system. This shows split unit system indoor, unit in curve and X. And the second picture shows the split unit system outdoor, unit in curve and X. So the indoor unit and the outdoor unit. So the location of split unit system in curve and X at lower ground floor plan. So the LG showing split unit system. Location of split unit system in curve and X, G floor plan. So we move to heat energy and heat transfer. What is heat energy? So heat is the flow of energy from a warm object to a cooler object. Heat energy is the result of the movement of tiny particles called atoms, molecules or ions in solids, liquids and gases. So these tiny particles are always in motion. They are either bumping into each other or vibrating back and forth. It is motion of particles that creates a form of energy called heat energy that is present in all matter. So this is the three states of matter, which is solid, liquid, gas. Solid is close to each other, then liquid, then it is move apart from each other in liquid form, and they are freely moving back and forth in gas state. So how energy is actually transferred? So heat transfer is when heat energy flows from the object of higher temperature to an object with a lower temperature. It will never do the reverse, which means that heat will always go to a temperature lower than that. So heat energy can be transferred by conduction, convection and radiation. So the picture in a blue background show the low movement, low temperature of atom. So the pink or red picture shows the high movement, high temperature. The high temperature shows that the atom colliding with each other more rapidly. So heat transfer in HVAC considerations. Conduction. What is conduction? Conduction heat transfer is heat energy traveling from one molecule to another. A heat exchanger in an HVAC systems use conduction to transfer heat. So heat does not conduct at the same rate in all materials. For example, all HVAC copper conducts at a different rate than iron or aluminium. So different elements, different rate of heat exchange. So what about convection? Convection heat transfer is when some substance that is readily movable, such as air, water, steam or refrigerant moves heat from one location to another. An HVAC system uses convection in the form of air, water, steam and refrigerants in ducts and piping to convey heat energy to various parts of the system. When air is heated, it rises. This is heat transfer by natural convection. Forced convection is when a fan or pump is used to convey heat in fluids such as air and water. For example, Many large buildings have a central heating plant where water is heated and pumped throughout the building to the final heated space. Fans then move heated air into the conditioned space. So for radiation heat transfer requires no method to transmit heat. All objects above absolute zero are said to radiate or project heat from its surface. For HVAC and refrigeration, the primary heat gain due to radiation is from solar radiation. Heat is radiated from the sun and transmitted to a building either by heating up the outer surface or transmitting through windows and skylights. Alternative and renewable technology in EBMV industry. Solar-assisted HVAC system. Solar-assisted HVAC system is a typical air conditioning that is powered partially or fully with solar energy. One common method is producing electricity with solar PV or other solar energy technologies, and the electricity is used to power the HVAC system. The other method is using solar energy to heat up the refrigerant used in the air conditioning cycle, thereby reducing the power input at the compressor station. So how solar thermal cooling works? The thermal collection unit is installed on the discharge side, hot gas side of the compressor. Free solar energy is injected into this hot refrigerant gas, increasing the kinetic energy of the molecules and the velocity and the temperature of the refrigerant. So the higher temperature of the refrigerant gas increases the delta temperature. We call it as delta T between the condenser coils and the outside air, which increases the heat flow out of the system. So the increased heat flow means the gas reaches the equilibrium point, which the conversion of the refrigerant from gas to liquid, earlier within the condenser coil, which also improves the effectiveness of the heat transfer and conversion to liquid. As the refrigerant passes from the condenser toward the evaporator, the heat pump's internal monitoring components will recognize that more than enough of the liquid refrigerant is of sufficient quantity and quality to allow the evaporator to be effective. With this excess cooling capability, the compressor can then slow down or stage off. The energy saving begins as the solar energy substitute for some of the energy formerly used by the compressors. So this picture shows the cycle of refrigeration with solar thermal heat. So what is the benefits of solar thermal cooling? The first benefit is it is sustainability, which is it reduces greenhouse emission due to using sun energy. Second one is adaptability. It can be used on new or existing HVAC systems. The third one is forward compatibility. When replacing an existing HVAC or HVAR system, the solar thermal components can just be repiped into the new system with minor adjustments. So the fourth one is peak demand reduction. The hotter the sun, the more efficient the system becomes. So the highest efficiencies are achieved during peak hours when demand savings may be available. Regulatory and legislation in the EBMV industry. The American Society of Heating, Refrigerating and Air Conditioning Engineers stated that all outdoor air intake and exhaust systems shall be equipped with motorized dampers that will automatically shut when the system or spaces served are not in use. Ventilation outdoor air and exhaust relief dampers shall be capable of automatically shutting off during building warm-up, cool-down and setback. When ventilation reduce energy costs or when ventilation must be supplied to meet code requirements. Enclosed parking garage ventilation system shall automatically detect contaminants levels and stage fans or module fan airflow 50% of levels of design capacity provided acceptable contaminant level are maintained. So license to a Malaysian standards 1231 2030. Mechanical ventilation and air conditioning stated that where permanent mechanical ventilation or air conditioning is intended, the relevant building bylaws relating to natural ventilation natural lighting and height of room may be waived at the discretion of the local authority. Any application for the relevant bylaws shall only be considered if, in addition to the permanent air conditioning system, there is provided alternative approved means of ventilating the air conditioned enclosure, such that within half an hour of the air conditioning system failing, not less than the stipulated volume of air specified hereinafter shall be introduced into the enclosure during the period when the air conditioning system is not functioning. The provision of the third schedule to these bylaws shall apply to buildings which are mechanically ventilated or air-conditioned. Where permanent mechanical ventilation in respect of lavatories, water closets, bathrooms, or corridors is provided for and maintained in accordance with the requirements of the third schedule to these bylaws, the provision of these bylaws relating to natural ventilation and natural lighting shall not apply to such lavatories, water closets, bathrooms, and corridors. License to Malaysian Standards MS 1525 2007. The SEMV system equipment. SEMV system equipment provides in one single package or more split system factory assembled packages means for air circulation, air cleaning, air cooling with controlled temperature and dehumidification, or the cooling function may be either electrically or heat operated, and the refrigerant condenser may be air, water, or evaporative cooled. Where the equipment is provided in more than one package, the separate packages should be designed by the manufacturer to be used together. Energy Management System (EMS). The Energy Management System (EMS) is a subset of the Building Automation System (BAS) function. It should be considered for buildings having area greater than 4,000 m² of air-conditioned space. Generally, a building automation system has three functions, which is control of equipment, monitoring of equipment, and integration of equipment subsystem. So for control of equipment, the purpose of the control of equipment is to save energy. This is performed by the EMS function of the building automation system. For monitoring of equipment, the purpose of monitoring the equipment is to improve the efficiency of the operations by providing centralized information of the current equipment conditions, providing historical information of equipment conditions, providing a management by exception function to alert the operator of any abnormal equipment conditions, providing analysis tools to aid the study of the equipment operations. So integration of equipment subsystem. Equipment subsystems are integrated for the purpose of improving safety or security. For example, in the event of a fire, air units can be used to create a sandwich system for smoke control. Indoor air quality, for example, by utilizing the smoke purging the system for periodic air purging to achieve good indoor air quality. Information management, by allowing information from multiple equipment subsystems to be stored and reported in a consistent format. So overall system reliability, the intelligent controller of an equipment subsystem may be configured to provide redundancy as a standby unit for another systems without incurring additional cost. So that's all for the presentation. Thank you and have a good day.